Hi everyone. Now let's look at exam typical questions. But before we even go through these questions, or before you even go through these questions, make sure that you have watched part 1. In part 1, I explained all the theorems that you are going to need to answer Euclidean geometry questions. Now, in Euclidean geometry, it is very, very important to read and understand the statement. Analyze the diagram, because that is where you will find most of your answers. So you'll find most of your answers through reading the statement. You'll find most of the answers through analyzing your diagram. So now, let's look at this one. In the figure below, A, B, C, D is a cyclic quad. So remember the theorems that has to do with the cyclic quad. In the circle centered at O, remember the theorems that has to do with center. And A and triangle DOP is drawn. DS is a tangent. Remember all the theorems that has to do with tangent. We are also told that DC is equal to BC. So here, these two chords are equal. So you can see that now we have an isosceles triangle, which is BCD. Angle CDS is equal to 40 degrees. So now CDS, so this angle here is equal to 40 degrees. That is angle D1. Okay? So if you look at angle D1 already, we are told that this is a tangent. So now if you look at angle D1, it is an angle between the tangent and this chord here. Now, the first question here, we are required to calculate the size of angle BDC. So let's check where is BDC now. Angle BDC, BDC. So now we are required to calculate angle D2. You can see that is in the isosceles triangle. Now, if you look at angle D2, you will notice that the angle that they are looking for, angle D2, is equal to angle B1. So angle D2 is equal to angle B1. Why is angle D2 equal to angle B1? Now, you can see that we have an isosceles triangle. So these are angles opposite, equal sides. Because we are told that DC is equal to BC. But now you can see again that angle B1. So there is angle B1. If you look at this chord here, and then there is a tangent here, there is angle between the tangent and the chord, so which is equal to 40 degrees. So now you can see that the chord DC subtended that angle there, which is B1. So that is a tan chord theorem. So this angle between the tangent and the chord equal to the angle subtended by the chord on the alternate segment. So now D1, that is given as 40 degrees, is equal to what? Is equal to that angle B1. So which is equal to what? Which is equal to 40 degrees. So that is a tan chord theorem. So let me put it in my diagram. So we are saying here we have 40 degrees. So we are saying also P1 is 40 degrees. And then, so that means D2 also is 40 degrees. Now you can just say, therefore, angle BDC is what? Is 40 degrees. Remember, the question was to calculate the size of angle BDC. So it is 40 degrees. Now, the question that follows, calculate angle C. Now, you see that angle C is in this triangle. Here is angle C in this triangle. So already we do have two angles. So we can calculate the third angle using sum of angles in a triangle, because we know that angles in a triangle, they add up 280. So, okay. Now, angle C is equal to 180 minus 40 degrees minus another 40 degrees. So angle C will be 100. Why? Sum of angles in a triangle. So angles in a triangle, they add up 280. So if B1 is 40 and D2 is 40, that simple means angle C will be 100 degrees. So now, after you have calculated an angle, it is very important to write that angle on your diagram. So the next question is, calculate angle A. Now, remember from the statement, they told us that A, B, C, D is a cyclic quad. And remember, opposite angles of a cyclic quad add up to 180. So now, if angle C is equal to 100, so that simple means angle A will be what? Will be 80 degrees. So angle A is equal to 80 degrees. Why? You just say these are opposite angles of a cyclic quad. And then this angle here is 80 degrees, opposite angles of a cyclic quad. They must add up to 180. So this is our number 1. This is our number 2. And then this is our number 3. And then the last question here, we are required to calculate angle O1. So here is angle O1, angle at the center. So remember, angle at the center is equal to 2 times angle at the circumference. So now, if angle A is equal to 80 degrees, that means the one that is at the center is twice as much. So angle O1 will be equal to 80 multiplied by 2. So that means angle O1 is equal to 160 degrees. Reason, it angle at center is equal to 2 times angle at the circumference. Angle at center is equal to 2 times angle at the circumference. Now let's move to the next question. Here, we are told that PON is a diameter. So you need to remember that a diameter will always subtend an angle that is equal to 90 degrees. So angle that will be subtended by this PON is 90 degrees. Now we are told that O is the center. Remember again all the theorems that has to do with the center. TM is a tangent. So this is another keyword, tangent. So remember all the theorems that has to do with tangent. So we are also told that OR is parallel. OR is parallel to PM. Remember the fun part of mathematics, if you have parallel lines, remember co-interior angles, corresponding angles, alternating angles. So all the theorems that has to do with parallel lines. NR and MM are drawn. Let angle M1 be equal to 66 degrees. Now, the first question here, we are required to calculate the size of angle P. Okay, now you can see that here we have a tangent. So here is our tangent. So this is a tangent. So we have a chord. Our chord here is MN. There is an angle between the tangent and the chord, which is equal to 66 degrees. So we can see that the chord MN subtended angle P. There is angle P. So now we can use tan chord theorem. So that means angle P is equal to what? Is equal to 66 degrees because it is subtended by that chord. Now angle P is equal to what? Is equal to 66 degrees. So this is a tan chord theorem. So we just put 66 there. They are both equal to whatever. Calculate the size of angle M2. So there is M2. M2 is subtended by PON. M2 is subtended by PON. So the PON subtended that angle there. Remember they said PON is a diameter, and the diameter will always subtend an angle that is equal to 90 degrees. So that simple means your M2 will be what? Will be 90 degrees. It is subtended by diameter. So M2 is equal to 90 degrees. So why? Because a diameter subtend right angle. Or you can just write angle in a semicircle. So this angle M2 is 90 degrees. Calculate the size of angle N1. Now there is N1 in a triangle. So in triangle MPN. So in that triangle already we do have two angles. So we can just calculate the third angle, because we know that angles in a triangle, they must add up to 180. So now to calculate N1, so our N1 is equal to 180 minus 90. 90 is your M2 minus 66 degrees. 66 is your angle P. So reason here is sum of angles in a triangle. Now 180 minus 90 minus 66, it will give us our N1 as 24 degrees. So let's write that 24 there. So our N1 is 24 degrees. calculate the size of O2. Let's check, where is O2? There is O2. Okay. Remember, from the statement we are told that these two lines are parallel. So we can see our F here. Here is our F. So we do have corresponding angles. So this angle and that one, they correspond. So that means O2 is equal to P. So our O2 is equal to angle P, but they are equal to what? 66 degrees. Why? We have corresponding angles. Why are they corresponding? Because PM is parallel to OR. They are corresponding because PM is parallel to OR. Okay, and then let's put it there that this angle is 66 degrees. Now calculate the size of angle N2. Where is N2? This angle. So we are looking for N2. Now remember again from the statement, they said O is the center. So if O is the center, that simply means OR is a radius, even O N is a radius. So these two are equal radii. Now we can see that we have an isosceles triangle. We can see that we have ONR as an isosceles triangle. Okay, so here is our isosceles triangle. So from this isosceles triangle, we can calculate the size of N as a whole. So we know that N is always equal to what? Is always equal to R in an isosceles triangle. So now we will say OR is equal to what? Is equal to ON. Why? Radii. Okay. So therefore angle N, so N, remember, that is your N1 plus N2, is equal to angle what? Is equal to angle R. These are angles opposite, equal side. These are angles opposite, equal sides. And then from here, we can just say angle N is equal to 180 degrees minus angle O2, which is 66 degrees, over what? Over 2. This is angle N as well as angle R. They are equal to 180 degrees minus 66 degrees divided by 2. So this will give us what? This will give us 57 degrees. So reason here, we have sum of angles in a triangle. So remember, N is made up of N1 and N2, but we already have our N1 is 24. So that simple means N2 is 57 minus 24. It will give us 33 degrees. So N2 is next question.